In this session, we're going to take a look at rational numbers. Before, we've taken a look at integers, integers being whole numbers greater than 0, as well as less than 0, as well as 0 itself being an integer. An integer, all integers are also rational numbers. However, there are more examples of rational numbers that go beyond just the integers. What is a rational number? A rational number is any number that can be written as the quotient of two integers. And remember, quotient is the answer to your division problem. So an integer, or excuse me, a rational number is any number that can be written as the result of taking two integers and dividing them against each other. Let's take a look at the number -2. Based on the definition of a rational number that I just gave you, is -2 a rational number? Well, yes, it is, because it can be written as the quotient of two numbers. The quotient would be -2 over 1. Is -11 a rational number? Well, sure it is. It can be written as the quotient of 11 divided by 1. These are both integers. These are both integers. What you're going to find out is every integer is a rational number because every integer can be written as a division problem with itself dividing by 1. So we've quickly seen then that all integers are rational numbers. But what about some numbers that are not integers? Let's take a look at the mixed number 4 1/3. Question is the mixed number 4 1/3 a rational number? Can it be written as the quotient of two different integers? Well, if you remember how to change a mixed number into a fraction, you take your denominator of the fraction, 3, you multiply it by your integer over here, 4. 3 times 4 is 12, and then you add your numerator up here to it. 12 plus 1 is 13. So your new numerator is now 13, and then you keep the same denominator that you had in the original fraction there. So the question is, once again, is 4 1/3 a rational number? Yes, because it can be written as the quotient of two integers, and the quotient is 13 divided by 3. A decimal number. How about the number 2.6? Is 2.6 a rational number? Can it be written as the quotient of two different integers? Well, first of all, it might be helpful to change 2.6 first of all into a mixed number. And what you do is you rewrite it. You take everything to the left of the decimal point. That's your whole number, the whole number portion of the mixed number. Then you take what's after it. What's another way of pronouncing 2.6? Well, you take this place that the 6 in, which is in the tenths. Another way of pronouncing 2.6 is 2 and 6 tenths. Now, by converting this decimal over into a mixed number, we can see that this mixed number can be written as a fraction or as a quotient of two integers. Take our 10, multiply it by the 2, that's 20. 20 plus 6 is 26. That becomes our top number, and 10 becomes our bottom number. So we see here then that 2.6 is also a rational number. And then if we were asked to take our fraction here, our quotient of two different numbers, 26 over 10, and we were told, get that back or convert it back into a decimal form, like what we have over here, the manner in which you would do that would be to take the top number and divide it by the bottom number. So we would just come down here and do 26 divided by 10. And when you work it out, you'll find out that your answer does take us back once again to the 2.6. And then that trails off there and we're left with 0 at the end. So you can convert a mixed number into a fraction, an improper fraction if necessary. And that's your top number divided by bottom. Those are your two integers there for your rational number. You can change a decimal into a fraction like this to divide top by bottom, and then you can also change a fraction back into a decimal form. As far as a number line goes, any rational number will have some point on the number line to which you can place that particular rational number. So for example, number -2 here, that is a rational number. So here's 0, here's -5, -2 is probably somewhere in there. -11, well, that's probably over here. 4 1/3. If you kind of divide this in half, 2 1/2, 3, 4 would be about right here, and 1/3's a little bit more, so that would be 4 1/3. And then 2.6, that's just slightly over halfway, so that would be about right there. So the question then is, which is bigger, -11 or 2.6? You should be able to answer this question just by looking at the graph. And the reason why is one of the illustrations we had earlier was that if you have a number line going across the page horizontally, the further to the right a number is, the larger the number is. So -11 is over here at the far left, and 2.6 is over here. The very fact that 2.6 is to the right of -11, -11, means it's larger. Is -2 or -11 bigger? Well, -2 is bigger. It's further to right on the number line. So once again, number line is helpful for us to see which numbers are bigger than others just by visually seeing the positions of the points on the number line itself. Quick review of a rational number, its definition. A rational number is any number that can be written as the quotient of two integers. That'll end it for session 24, rational numbers.